The reaction between metallic copper and silver nitrate solution is slow but dramatic. With the benefit of time-lapse photography, you should be able to make at least 3 observations. Firstly, solid appears to deposit on the surface of the copper and fall off when it becomes too heavy. Secondly, some of the copper metal appears to dissolve. Thirdly, the solution turns blue from the surface downwards, an interesting phenomenon. Let's start by looking at aqueous silver nitrate, a clear, colourless liquid. At the molecular ionic level, the negatively charged nitrate ions occasionally collide with the positively charged silver ions, here coloured blue. But the water molecules then pull them apart. Notice once again how the oxygen ends of the water molecules point towards the positively charged silver ion, whereas the hydrogen ends of the water molecules point towards the negatively charged nitrate ion. A 1 molar silver nitrate solution contains about 55 water molecules for each silver ion and nitrate ion. The ions are separated from each other by, on average, about 3 water molecules and only collide occasionally. Silver nitrate solution contains billions of hydrated silver and nitrate ions moving around amongst the water molecules. Metallic copper has properties consistent with a bonding model involving mobile or delocalized electrons. We can imagine its structure to consist of vibrating copper ions, here represented as yellow spheres, glued together by a sea of electrons, represented by the fuzzy cloud. We will use this representation to distinguish between a metal atom and its common ion. The formula for solid copper should show its building block, the copper atom. Metal ions held together in a lattice by an electron cloud is a useful model for metals. Now let's go back to the reaction and imagine what is happening at the molecular ionic level. First, we see hydrated silver ions migrating to the surface of the copper. As they gain electron clouds, a copper ion is ejected from the lattice. A nitrate spectator ion passes by, and another silver ion joins the surface. For every 2 silver ions that attach, 1 copper ion is ejected and hydrated. Each copper atom leaves 2 electrons behind as it dissolves in the solution as a hydrated ion. Each silver ion is stripped of its hydration shell as it attaches to the surface and gains an electron to become an atom. The equation for this reaction should show the relative numbers of atoms and ions involved overall. As the reaction proceeds, for every 2 silver ions that gain electrons, a copper ion is ejected. Oxidation reduction involving the transfer of electrons can be likened to acid-base reactions involving the transfer of protons. Both involve a tug-of-war for subatomic particles.